Welcome to recording 1B in our series on working with radicals for Unit 5, Chapter 5 of Mathematics 2200. We'll be looking at radical expressions containing variable radicands and the restrictions on those variables, and the process of converting from entire radicals to mixed radicals and vice versa. Recall from recording 1A, if a radical represents a real number and has an even index, the radicand must be non-negative. In other words, the radicand must be greater than or equal to 0. Looking at our first expression, the index here, it's a square root, so the index is 2. That's an even index. We cannot do the square root of a negative number, so our restriction is that the x value must be greater than or equal to 0. That's our radicand. The fourth root of x, you have an even index, and the radicand this time again is x greater than or equal to 0. And the next one, the index is 3, so that's an odd index. There's no restriction, so we could choose any real number for the values of x. X minus 5, that is the radicand in the next one. We have an index of 2 because it's a square root, even index. So the x minus 5 must work out to be greater than or equal to 0. That means x must be at least 5. We can do a bit of rearranging by adding 5 to both sides here, and we have x is greater than or equal to 5. For the last one, we once again have an even index of 4. That means 1 minus 3x must be greater than or equal to 4. A little bit of switching around. Negative 3x has to be greater than or equal to negative 1. There is a little bit of a fly in the ointment here, though, because we will need to divide both sides of this inequality by a negative number. Once we do that, we've got to change the direction of the inequality symbol as well. So our restriction becomes less than or equal to, x is less than or equal to, a negative divided by negative will give us a positive 1/3. We move now to converting mixed radicals to entire radicals and stating restrictions. Now remember from our review in recording 1A, the coefficient of the radical must be raised to a power or an exponent equal to the index. That means it must be squared, because our index in this case is 2. And we have an a right there left over from, that's the original one. So exponent to an exponent, we multiply, we have a to the 8 times a, that other a is a to the 1, and therefore our final answer is the square root of a to the 9. We are asked to state restrictions. We can go right back to the beginning and do this. The radicand must be greater than or equal to 0, so that means our a has to be greater than or equal to 0. For the next one, let's deal with the restriction first. Actually, there is no restriction. We have an odd index, therefore no restriction on the radicand or on the variable. Let's follow the process for writing the the entire radical. We want to bring that 5b, the coefficient, under the radical symbol. So before we do that, we have to raise it to a power equal to the index. That's cubed. And then it's times the 3b squared that was already there. So we wind up with 5b cubed. We've cubed the 5, that's 125. Cube the b times 3b squared. And 125 times 3 is 375. And we add the exponents on the b's to get b to the 5. Now we need to go the other way and write the mixed radical from the entire radical. We also need to get restrictions. We have an even index here. So we will have a restriction. We'll worry about that toward the end. It's a little easier to do it then. We have the fourth root of c to the 9. So we need a perfect root. We need a perfect fourth root. To do that, we think of c to the 9 as c to the 8 and then c to the 1. Notice that 8 is a multiple of 4. So that's the largest multiple of the index. Fourth root of c to the 8th, the easiest way to find that is to divide the index into the exponent, and we get c squared times the fourth root of c. If you don't like what I did there with the index and the exponent, recall from recording 1a. We have the fourth root of c to the 8 can be expressed using rational exponents or fractional exponents. The top number here, or the exponent here, becomes the top number in our exponent. The index becomes the denominator. So again, we have c to the 2, c squared. Now, the restriction. Here the radicand is only a c, so that's why it's easier to find, a little easier to find the restriction at the end. Next one, the square root of 48y to the 5. I think of it like root of 48 times the square root of y to the 5. The largest perfect square factor of 48 is 16. So we have 16 times 3 for 48. And the largest multiple of the index, which is 2, that can come out of the 5 is 4. So we express this as y to the 4 and y to the 1. The square root of 16 is 4. Square root of 3 is not perfect. Square root of y to the 4, the index is 2, so we divide the 2 into the 4 to get y squared. And then we have the square root of y to the 1 left. So I started off by separating things, separating even further. Now it's time to recombine. The 4 and the y squared, they're outside the root sign, so we'll put them together. And the root 3 and the root y, they go together to get root of 3y. The restriction is that 3y has to be greater than or equal to 0. Divide both sides by 3, and we've got y greater than or equal to 0. In conclusion, if there's an even index, you must have a restriction on your radicand. When converting from mixed to entire radical form, first express the coefficient as the power of the index before putting it under the radical sign. And when converting from entire to mixed radical form, make sure you express the radicand as a product of a perfect root and a non-perfect root.